Happy Thursday. I wanted to take a moment to go through the exercise for today. There are two parts to this. We have our mixed methods, which is just what we've been doing in the past. And then we also have our determining factoring type. Now, the determining factoring type is a times one. However, I don't want you to panic over the time. You have 200 seconds to do 5 problems. I made it this way to where you have plenty of time to think. If you're somebody who gets anxious by the time, I encourage you put a post-it note over that timer, and that will help you out. But really, there's no math involved in it. It's just recognizing your strategy and choosing it from there. So I'm going to go ahead and start with this one to talk about how do we do this. All right, so I'm going to go ahead and click start, and I'm just going to talk my way through these. All right, so here's what we have. We have what method of factoring should first be used. And here are our options. We have greatest common factor. Now, greatest common factor, do these have anything in common? Well, no, this is a t cubed and this is a -1. That one won't work out. All right, next, difference of perfect squares. Can I break this up perfectly? Well, t to the third power, I can't really split that up perfectly in half. I can't really have t to the 1.5 and t to the 1.5. That's not going to work out for us. So we cannot do difference of perfect squares. Trinomial factoring, those are the ones like we've seen x squared plus 7x plus 12. Think about it, tri means that there are 3 terms. This one only has 2 terms. So the answer for this one is this one does not factor. All right, let's look at the next one. We have 5xy plus 14x. All right, let's go through. First off, does this have a greatest common factor? Well, yeah, let's look. This one has an x in this term and an x in this term. X and x, my first step would be to do a greatest common factor. All right, let's look at this one. We have d to the 4th minus 9. All right, first off, does this have a greatest common factor? Well, no, this one has d's and this one has 9s. Nothing, neither of those work out. So, difference of perfect squares. Hey, we're on to something. D to the 4th power could break up into d squared and d squared. -9 could break up into 3 and -3. This would be a difference of perfect squares. All right, next one. 3x squared minus 3x minus 90. Let's start off again. Greatest common factor. Well, let's look. Do we have anything we could divide out of all of these? Well, we've got a 3, a -90. All of those are divisible by 3. So this would be a greatest common factor. All right, here we go. We have 9 minus 4r to the 6th power. All right, well, let's look for a greatest common factor here. Well, this is divisible by 9 and 3. This one's only divisible by 2's and r's. We don't have a common factor. All right, difference of perfect squares. Let's look here. Well, hey, I'm seeing something. 9 could break up into 3 times 3. We have a minus, so we'll have 1 plus, 1 minus. 4 breaks up into 2 and 2. And finally, r to the 6th power breaks up into r cubed and r cubed. This is the difference of squares. All right, I'm going to keep going even though I've gotten my 5 and I really talked through all of these, but let's go ahead and keep going. We have v to the 6th minus 100. All right, v to the 6th minus 100. Does this have a greatest common factor? No, this does not. This is v's and this is 100s and 10s. Difference of perfect squares. Can we break this up perfectly? Well, yeah, v to the 6th would break up into v cubed. I have a negative, so 1's plus, 1's minus. And then finally, 100 breaks up into 10 and 10. All right, let's take a look here. First off, greatest common factor. Well, I have an x cubed minus 13x plus 36. Now I don't have a greatest common factor. Difference of perfect squares. Well, no, this isn't a difference of perfect squares. This has 3 terms. That's not going to work out. All right, now it'd be very tempting to click trinomial factoring, but they're trying to be pretty tricky here. In order for this to work, let's take a look here. X cubed, well, usually with trinomial factoring, this will be an x squared, and x squared will be able to break up into x and x. But this has an x cubed. That's not going to work out. So this one is going to be a does not factor. All right, here we go. X to the fourth minus 5x cubed minus 24x squared. As I'm looking through these, I have an x in this term, an x in this term, an x in this term. This is a greatest common factor. All right, and here we go. This looks pretty good. So for this one, this is looking like, well, greatest common factor. I don't have anything that I can divide all of those by. Difference of perfect squares, well, we've got 3 terms. And then finally, 5x squared plus 41x plus 42. All right, well, that does look like that should factor out. I'm pretty sure that would be a trinomial factoring. Oh, did I just click that? There we go. All right, and one final one to go over with you guys. I have 4u to the 5th, v to the 4th plus 3. This one does not have a common factor. This is not a difference of perfect squares. First off, this term would have to be a negative, but this would be u to the 5th. You can't split that up perfectly. Trinomial factoring, I need 3 terms. Tri means 3, so this one would be does not factor. All right, so guys, please, please, please take your time with this. Do not worry about the time to beat. Feel free to put a post-it note over there or just hold your hand up. Some of us don't really do well under the pressure, but this is a really good activity to take a look at what method should you be using. And all you have to do is 1 every 40 seconds. That is reasonable. So once you're done with that, you do have the mixed factoring methods, which compares all of those, and then we will have a short quiz tomorrow. Please email me if you have any questions. Good luck. Have a wonderful day.